Muy buenas tardes a todos ustedes, queridos asistentes, ingenieros, público en general. En nombre del capítulo de Ingeniería Mecánica y Mecánica Eléctrica, de su presidente, ingeniero Ricardo Santillán, y de su junta directiva, el cual me honro también en integrar, le damos la más cordial bienvenida a esta semana de la Ingeniería Mecánica y Mecánica Eléctrica que estamos desarrollando el presente año del 1 al 4 de diciembre del 2014. Desde ya le agradecemos a todos ustedes su participación. En esta semana, la Junta Directiva ha considerado pertinente realizar una serie de conferencias, como ustedes han podido apreciar, que hemos iniciado el lunes 1, con importantes conferencias como relacionadas a la parte de energía. En este tema hemos tocado lo que son eficiencia, operación y servicio en calderas. También tuvimos una conferencia importante relacionada a lo que es proyectos de energías renovables, ¿no?, en las zonas altoandinas, que hoy en día mucho se vienen aplicando en estas zonas, dadas los proyectos del gobierno que vienen relacionados al tema de inclusión social. El día de ayer también tuvimos otra conferencia relacionada a lo que es conversión de calderas a gas natural, que como ustedes saben, hoy en día el tema del gas natural es un energético que se viene desarrollando mucho en nuestro país. Como bien anunciado nuestro moderador, el día de hoy tendremos, y gracias al apoyo de la empresa ABB, que siempre comparte con nosotros su presencia y su apoyo en todos los eventos, o en la mayoría de eventos que desarrollamos, realizaremos una importante exposición. Quiero mencionar también de que el capítulo el próximo año realizará una edición más del Congreso Nacional de Ingeniería Mecánica y Mecánica Eléctrica, denominado CONIMERA, que se desarrollará del 24 al 26 de junio. En esta oportunidad, los temas a considerar serán temas muy importantes que se vienen desarrollando y que sirven de mucha utilidad para nuestro medio. Están relacionados a lo que es energía, mecánica aplicada e innovación tecnológica, por lo cual quiero resaltar e invitarlos a participar en este evento, no solamente con su presencia, sino también con la presentación de trabajos e innovaciones que ustedes puedan tener en algún proyecto que vienen desarrollando. Muy bien. Quiero compartir también en estos momentos la presencia de nuestro directivo, el ingeniero Luis Maita, por favor, que pido ponerse de pie, también que nos está acompañando. Muchas gracias, ingeniero Maita. ¿No? Y resaltar muy bien, como dije, la presencia y el apoyo de la empresa ABB con esta importante conferencia que estamos brindando el día de hoy, ¿no? Muy bien, a todos ustedes, muchas gracias por su presencia y esperamos tener una importante conferencia en provecho de ustedes. Muchas gracias.
Hi everyone, and you are very welcome to this evening about Softstarters. As I said, my name is Carl. I'm from Sweden, which means that right now in my home country it's cold weather, it's even a little bit of snow, and I'm very happy to be here to see the sun and the warm temperature. Last time I was in Peru, I took the opportunity to travel to Machu Picchu in Cusco and see the beautiful heritage that you have here in Peru. You have really something to be proud of. So, this evening is not going to be about me, of course. It's not going to be about the product itself either. This is going to be about you and how we at ABB can help you to secure the reliability of the motors that you are using, to help you increase your efficiency when it comes to installing and handling electrical equipment. And also we will show you how you can increase the productivity in the many processes that you are running with motors. First of all, I would like to start with a short brief video about the new product. Then I'm going to talk about motor starting in general. Motor starting with different methods. And then we're going to go into the new soft starter. That is something we are really proud of at ABB and we are introducing this year. Okay, sorry that the rock music fell away in the beginning. That was very brief about the product, and I don't think that you could get everything, so I will spend the next 1.5 hours to tell you more about the product. But before we go into the detail about the product, I would like to mention something about motor starting and why motor starting is so important for all of us. It has to do with this. If you look at the electricity consumption in the world today, around 42% is consumed by the industry. There's a lot of electricity consumed by the industry in the world. And out of this 42%, the industry uses 2/3 of that to start, to operate, and to stop electrical industrial motors. So in total, that means that 28% of the world's electricity consumption comes from motor operation. So of course, with so much electricity being spent, it is important what we do with it, how we run the motors, and how to make this more efficient. Today, in the world, there are currently around 300 million electrical motors installed and running. 300 million. And this is a number that is growing steadily every year. Out of these 300 million motors, around 90% of them are running and used in full speed applications. So when we talk about improving starting of motors, we cannot only talk about the 10% of the motors where we are allowed to vary the speed. We need to talk also about the motors that has to run in full speed and how to make them behave better. So with all this electricity consumed by so many motors, imagine the potential we have to improve the world by doing motor optimization. So really my first message to you today is that it is important, it does matter what kind of starting method we choose, because there are so many motors we are talking about and there's so much electricity consumed. To give you an idea of how important the electrical industrial motor is today, we have a short video showing different examples of where you will find the motor.
Coming up, do you know just how much of modern life depends on the humble electric motor? In a moment we'll be talking to a motors expert from ABB. But first, here's the weather. Well, after a rainy start, the weather is expected to break around lunchtime, with sunny spells lasting well into the evening.
Make sense of everything. This is not imagination. Just hear me out this time. We thank each other for what we have and congratulate the other for standing there to urge us on. So don't you dare say anything like this is not what's meant to be. It's about time that you saw this is who we are now. Stand up straight and face the front. Are you listening anymore? The time to change isn't now, because this is who we are. Don't tell me that this isn't happening just because you never saw the light coming from a distance. And when the sulfur rain comes pouring, do you think it's going to be Are you listening anymore? The time to change isn't now, because this is who we are. We'll never start again. We'll keep on moving forward. Don't you dare say anything like this is not what's meant to be. It's about time that you saw this is who we are now. Stand up straight and face the front. Are you listening anymore? The time to change isn't now, because this is who we are.
Okay. As you can see, and as you probably already knew, there are industrial motors that are running this world. They are driving all the kind of processes that we rely on. The water that everyone needs to use every day. The mining industry uses tons of motors, and you have a big mining industry here in this country. Transportations, electricity, all of it depends on motors. And ABB has been there from the beginning. We were part of the movement that invented the electrical motors for more than 100 years ago. And for equally long time, we have had different starting methods to start and stop these motors in different ways depending on different needs. And our current lineup, briefly, looks like this. We have the direct online starter that uses a contactor to give full voltage to the motor. It's a start that is very fast, it's a stop that is very fast, and it's a very popular starting method. Then we have the soft starter. The soft starter is also for full speed applications, but now we can start softly and we can stop softly, with a lot of advantages for that. But on top of this, we have also the possibility to change the speed of the motor. And we do that with a variable frequency drive or variable speed drive. With the drive, we can change the speed of the motor, we can do a soft start and a soft stop. So from ABB we have all these three ranges, and they are all very good products. And I thought I would spend a few minutes with you to go through a little bit more in detail with each product, so that you get a feeling for when it's a good option to select the direct online starter, when it's a good option to select the soft starter, or when to select the drive. It can be good starting points. And after that, we will go further into the soft starter, of course. And I've been working with starting methods with ABB for several years, and I'm happy to answer all your questions regarding starting methods, or especially the new soft starter that I'm going to present later. But I'm happy to take those questions after my presentation in about an hour. So make a note if you come up with a question, and we will address them later. We start with the direct online starter. This is the traditional starting method. It has always been there. It's basic and simple to understand. It will give full voltage to the motor directly, and then it has no control of how the start is made. With that I mean the starting time and stopping time will only depend on the motor itself and the load it's driving. We don't have any settings for change how the start will be. It's possible to use the contactor, that is the active part of the starter, and combine that with other products to create a more complete starting solution. For example, on this picture, we have the thermal overload relay that will prevent the motor from being damaged by overload. We also have the circuit breaker that will protect the motor from short circuits. It's the most compact starting method. It's also the cheapest one to buy. That's why it's so popular, and for this reason it's also mainly used for starting smaller motors. But there are some things that I think you should be aware of that are consequences from using a direct online starter. We know that it's compact and that it's cheap to use and easy to install and understand. Those are the main benefits. But we can run into some problems. For example, we can experience that the voltage disappears during the start. Not disappears, but it drops. And this can cause problems. We can also experience that the short circuit protection will trip during the start. And this comes from the way the current is behaving during the motor acceleration. So when we start the motor, what happens at first is that we will get a very high inrush current, a peak in the current that can be as high as 20 times the normal current. Of course, the current will go down, and during the start it will follow the characteristic of the motor. But this current peak is something that we need to think about when we design all the other equipment in the panel that we're able to run this motor. Then we can also experience problems with mechanical wear and tear, products that are damaged, and slip ring belts. This comes from the characteristics of the torque during the start. The motor is often very powerful during the start, and it will start with a lot of extra torque that may not be needed, and the acceleration will be very fast. So this is something to think about before selecting direct online starter. Then we have a variant of the direct online starter we call the star delta starter. And the star delta starter utilizes the possibility to connect the motor in a star connection and in a delta connection, and that we can change between those two connections during the acceleration. So with the star delta starter, we will have the possibility to reduce the starting current during the start, which is very good. We avoid some of the problems, especially for small applications, small loads. We will reduce the torque during start as well, also very good. But we will get rapid increase of the torque when we switch from the star to the delta connection, because the delta connection is so much stronger, gives so much more power to the motor. So when we switch between these two connections, we can have a jump in the torque, and this can cause some problems as well. And to be honest, the star delta starter is a little bit complicated to install. It's a lot of cables, it's a lot of products, and it takes a little bit more time to install it. Something to be aware of as well. So I thought I will show you a quick example of how the start will look like for different kind of loads for the star delta starter. So we start with a very light start. We have a unloaded motor. What will happen when we start? Well, we can see that we can reduce both the torque and the current quite much during the start. And this is really good. This is a good solution for a small load. When we have a medium load, this is typically a pump or a fan. We will see that the acceleration will be slower. So when we change between the star and delta connection, we will see a drastic increase of the torque. And this can cause a lot of problems. This can also lead to very high peak currents, something we need to be aware of. And if we have a very heavy load, it can be a crusher, it can be a transport band that is heavy loaded at start. When we press the start, nothing will happen at first. The motor will be standing still and just making a noise. And then, after the 10 seconds, we will do a direct online start when we go over to the delta connection. So to summarize, for the star delta, it works very well for a small load. It doesn't work at all for a heavy load. And for a medium load, it can cause a lot of problems, even more problems than the direct online starter will do. Something to think about when designing a starting solution for a motor. Sorry. Okay. I would like to talk to you about the drive as well. A starting method that is getting more and more popular. The drive will give you full control of the acceleration, full control of the current, and full control of the torque. So it's a very versatile starting method. It will enable you to reduce the energy consumption of the motor by reducing the speed of the motor when you don't need a full speed. For that reason, it's very good. So that is why it's very often used in process industry to obtain process control. But there are some things, there are some concerns with the starting method. So I would say that it's only when you have a motion pattern of the motor that needs to look like something like this. It goes up and down during the day. Then you should definitely pick the drive as your starting method. But if you can run in full speed, you should consider another starting method because there are some concern with this technology. For example, it is expensive to buy. It is the most expensive of the three starting methods. It's quite big and heavy. A comparison. A soft starter for a 200 kilowatt motor has the size of something like this between my hands. And the weight of it will be around 15 kilos. A drive for the same motor will be of the same size as I am. It can be 2 meters tall, 1 meter wide, and the weight can be 200 kilos. So it's a completely different kind of product that needs a completely different kind of equipment to even install. The drive will create harmonics. Harmonics are overtones, disturbances on the network that comes from the way that the drive is changing the frequency. And this can cause problems for other equipment in the network, which puts higher requirement on how to install the products with proper grounding of the cables, for example, and have good quality cables that can handle this. You don't run the drive in bypass mode, so that will always be running with the IGBTs. And that means that it will generate a lot of heat in the panel. I will give you an example. A soft starter running on the thyristors for the 200 kilowatt motor will generate around 1000 watts. when we go in bypass mode with a soft starter, we reduce that energy consumption with 90% down to 100 watts, while the drive will consume more than 3,000 watts in heat. Something to think about. It's not always suitable to reduce the speed of a motor. Sometimes the application will not behave well if you reduce the speed. It can cause some problems. So, if you don't have need for changing the speed, you should consider another starting method. That's the message. Okay? Let's continue with the soft starter. The soft starter can do a soft start, of course, but also a soft stop of a full speed application. For that reason, it will reduce the starting current. It will reduce the starting torque. It will reduce the acceleration of the motor. And for that reason, it can save a lot of money for the user of the motor when it comes to less maintenance and service cost for the equipment. If we are going to do the same start as before, but with a soft starter for the unloaded motor, we can see that we now get a similar torque and similar current as a direct online start, the star delta starter. So it both works very well. For the pump, now it's getting very interesting, because the soft starter never gets any drastic increase of torque, which means that it's a much better starting method for the pump. And for the heavy load, we can also start it because we can change the amount of torque that the motor will get. So we can adapt it for different loads. Okay. Let's go into the new products and all the things we can do with the PSTX. The PSTX is the new generation of soft starters that takes the lead, the technology lead for soft starting on all markets. Today, or we released this some months ago, in July it was released worldwide. And step by step we have introduced this product to more and more markets. And I'm very happy to be able to introduce the product to you and the Peruvian market today. We have already tried this product in Peru with great success in harsh environments. And I will come back to that later. We have also tried the product in many countries, in different continents of the world, in different environments, applications and segments. And it's really showing strong results, and we have a lot of happy customers so far. To present this product, I would like to give you 3 examples of real customers and what they have told us about their experience using our soft starters. I will tell you about one customer who could reduce his starting currents by 60% by using our soft starters. I will also tell you about a customer that could build panels that were 20% smaller thanks to our soft starters. And I will tell you about a customer that got 100% longer lifetime of his pumps thanks to our soft starters. Okay, we're going to go through them one by one. Let's start with the first one. This is a customer that is based in Italy. It's an HVAC specialist, which means that they are making equipment for air conditioning and ventilation. And in this case, this company that is called Ross, they are making the air conditioning units similar to the one you can see in this room. And they had a specific demand that they needed to do a very fast start due to the need of the scroll compressor. And that start was not allowed to bring a high current because they need to install the equipment in a lot of buildings, not only in the heavy industry. So they turned to ABB, and we were able to give them a starter that could start almost as fast as a direct online start, but with 60% lower current. And they are really happy and are now using this for their ventilation equipment. We call this experience for secured motor reliability. And I would like to show you a couple of examples of new functionality that we are bringing with this soft starter that can help you and your customers to secure the motor reliability in your processes. I will tell you about that from ABB. We are now offering 3 different kinds of current limit. Current limit is a feature that will allow you to put a maximum level of how high the current is allowed to be. And from ABB, we have now 3 different methods for different needs. I will also tell you about our new motor heating feature. We can use the soft starter to heat the motor when it's needed. I will talk about that as well. And I will tell you about that we have now a complete protection of the motor included in the soft starter. So the motor will be better protected than ever before with the PSTX. So let's start with the first one. Current limit. Current limit has been a feature that has been very popular for many years now. It is used by almost everyone. It allows the customer, the user, to put a maximum level of the current during the start. Very good, because that allows you to design the rest of the equipment according to this. But we are also introducing the dual current limit that allows you to have a lower current limit during the first seconds of the start. And when the motor is starting to accelerate, we can give extra current. This is good when we are starting in a weaker network. But the new thing with the PSTX is the current ramp, that we can increase the current softly during the start. And this is very good when the transformer is not that strong. Especially transformer can be a little bit tough to start in the beginning, and it will need to start it more gentle. So this is the softest start that you can get. It's really good, and this will solve a lot of problems that we otherwise could see in installations far away, in mountain areas, in mining industry, or on platforms out in the ocean where the network can be unstable. We are also now introducing, as I said, the motor heating feature. Why do we do this? Well, when you have a motor, it can be installed in a lot of different environments. For example, in Sweden, where I'm from, we sometimes need to install the motor outdoor. So what happens now in December? Well, it comes snow, the temperature goes below 0, it gets a lot of wet and cold. So when we try to start the motor, the start would be very, very tough because the motor can even freeze. So what we have to do in Sweden is to have a heater around the motor to give some power to heat it up before we start. But with the PSTX, we have included this into the soft starter because we are now have the possibility to use the windings inside the motor as heating elements and give power to them, not in a rotational magnetic field so that the motor will spin, but just in a way so we use them with DC power from the AC network and heat up the resistor and warm up the motor from the inside as a pre-starting functionality. This is not only good in a very cold environment, because it's very good in the cold, but you can find cold environments not only outdoors in Sweden, but also indoors in different kind of cold rooms, like when you have ventilations and so on, and cooling. And also very good in countries or areas where you have high humidity, tropical areas. Because the moisture, the humidity can get inside the motor and it can be damaging for the motor. With the preheater, we can warm up the motor first, make sure that it's dry, then we do the start. This will increase the reliability of the motor and make sure that it lives for a longer time. It's very nice. Okay. Then we have motor protection. This is something that is very popular to include in the Softstarter today. The possibility to detect different kind of load conditions, abnormalities. For example, you can have a transportation band that suddenly someone put extra weight on the transportation band and the motor will run tougher and tougher with higher current. This can be okay for a few seconds, but if you run for too long time, the motor will be damaged. The Softstarter can detect this and stop the motor. It can also detect when the load is disappearing. And I will show you an example of this in just a minute. And with the PSTX, we include protection that can be connected to the PT100 and PTC elements in the motor, so we can monitor the actual temperature inside the motor. The difference between these two, the PTC and PT100, is that the PTC will give a digital signal to the Softstarter when the motor has passed a certain temperature. The PT100 will give the exact temperature of the motor all the time, so you can monitor it. But something that is completely new is that we are including protection against network irregularities. Over voltage, that can happen. The voltage goes up. Under voltage, when the voltage goes below. If this happens, it can damage the motor. It can make it behave differently. We can detect it, or we can stop the motor. Or why not just give a warning signal? That is also possible. You don't need to stop the motor if you don't want to. We have even included earth fault or ground fault. So the Softstarter can detect if there is a leakage from one of the phases to ground. It doesn't have the accuracy to be used for personal protection, but it's accurate enough to keep the motor safe. So it's for protection of the motor. But if not all these protections are enough, why don't design your own protection, which is possible with the PSTX. You can get an external measurement device of some kind. It can be, for example, the earth fault protection that we have in the ABB product portfolio with high accuracy. You can buy that as an accessory and connect it to the Softstarter. Why not go to another company and buy a level meter for the water tank and use that as a protection? Or any kind of device that will measure something and give a signal to the Softstarter when something has happened. And you can choose to display this as a fault, or you can stop the motor automatically. So it gives you much better protection. To show you what underload protection can be good for, I have a short video that will give you an idea. So this is the underload protection. Imagine that you have a pump system like this. You are pumping water. But for some reason, the water starts disappearing, which means that the water disappears from the pump and is running dry. And what will happen? Well, the pump is not designed to run without water. It will be damaged by this. So if you do this too much, you will have to buy a new pump. With the PSTX and also the PSE soft starter from ABB, you can detect this and you can stop the motor if it happens, saving the pump and saving a lot of money. Okay. Let's take a look at the second customer case. This is a customer from China. This customer is a system integrator, and they are specialized to build starting solutions for crushers for the cement and mining industries. Crusher is what we call a heavy-duty application. It's very tough to start, it's a lot of current, and in this case, it's also installed in a very dirty environment. So this company, they were using a competitor soft starter, but they were not satisfied with the size of the panel, and they turned to ABB. And we offered our solution, which has the bypass included in the soft starter, and also has a very strong design of the firesters and with a high starting capacity. So we could use a smaller soft starter than the competitor had to offer. The result, the whole panel became 20% smaller. Not only the soft starter, the panel. So of course, this system integrator, they are saving a lot of time and money on this and have easier to gain business. And we are very proud to be able to help them. The value that this company experienced is something that we call improved installation efficiency. And I would like to show you a couple of examples of how we are improving the efficiency when it comes to install and run and operate the soft starter. I will tell you about the new keypad that is detachable, which means that you can remove it from the product to put it on a panel door. I will also tell you about that we have now made a built-in bypass a standard for our soft starters, so that you always are sure that you have the bypass. And I will tell you about the new, more flexible way to do field bus communication. Okay, let's start with the first one. With the PSTX, the keypad is removable from the product. So you can take it off and you can put it on your panel door and just connect it on the back with a cable. A cable that is included as well. Why would you like to do this? Well, if you would like to make a safe installation where the operator never have to open the panel door just to monitor what happened with the motor, or change the setting, or check the status of the soft starter or the motor. Because if you open the panel door and still are running the process, there is a big risk of danger, because you have high voltage and you have high currents in the panel. If you put the panel on the door, you don't need to worry about that, and you can monitor and you do change of settings without put yourself into any risks. And we think this is so important at ABB that we have make sure that everyone gets a keypad that they can put on a panel door. Before, we offer it as an accessory, something that you had to pay extra for. Now it's included. And it's so easy to install. You just need to punch or drill a hole in the door and put through the hole here, and you had the nut to lock it on the other side, and then you're done. Very good. This keypad has the protection class IP66, which means that you can wash this one with water. You can install it in harsh environments with high humidity, or where you need to clean the panel with water for some reason, or even out the door. It's very robust, very reliable. And to make it even better, we have included a lot of features in this one, like a start button, stop button. You have them available on the keypad. You don't need to do any wiring for extra equipment for start and stop. There's a lot of nice things I would like to show you by using this keypad. And if I have time, I will show you a simulation and a demonstration on my computer screen. If I don't have the time, we have a couple of Softstarters outside this room that you can try with yourself, connected, and you can try to do settings. It's even possible to do a simulated start and stop, so you can see how it behaves. Of course, it's included in Spanish, the menu system. In fact, we have 15 languages included in this one. So if you would like to export the Softstarter somewhere else, you don't need to worry about the language. We have also put a lot of effort into making setup and using the Softstarter as easy as possible. For example, the display is graphical, which can show text and numbers and even pictures. And we have assistants included, which means that with just a few clicks with the buttons here, you can prepare the Softstarter for start. It's very easy. The next example I would like to talk about is the built-in bypass. A bypass is a very important device to make sure that you're not using the fire resistors more than you need to. You would like to do it. You would like to have the bypass because you would like to save the fire resistors so that you can use the Softstarter for a longer time. And you would like to save energy from the heat losses. And this is so popular and this is so common today that we have decided to do the job for you and include the bypass into the product so that we can make the product more compact. And thanks to this, you don't need to worry about selecting the correct bypass. You don't need to install it. You don't need to verify that it's working because we have already done that from the factory so that you can save some time because we think the bypass is very important. Communication. Communication is something that is getting more and more popular, to be able to have contact with the Softstarter from a distance. And we have made this very easy now. We have made sure that Modbus RTU is included in the Softstarter so that you don't need to buy an accessory or install an accessory. You just connect the two wires to the Softstarter and set it up for Modbus. Very fast, very easy, very cost efficient. If you would like to use a more sophisticated protocol, we are offering now the new Anybus communication module. With the Anybus module, you can use Profibus, DeviceNet, Modbus TCP IP, or Ethernet IP. All the major protocols. And it's very easy to change protocols by just changing the accessory. And if you today already have an ABB Softstarter installed with Fieldbus communication, they are using the Fieldbus plug from ABB. And of course, we are also offering support for that, for a retrofit installation. Diagnostics. This is really exciting. This Softstarter is more clever than any Softstarter before. It can calculate more than any other Softstarter. For example, if you have this overload condition that I talked about, someone put an extra load on the motor and it's running more heavy, the current goes up. You can do this for some time before you need to stop. But for how long time can you do it? Until now, you had no idea. You need to use your experience. With the PSDX, the soft starter will tell you how long time you can run the motor. So you know that if it's 10 minutes left until it will trip, is it 15 seconds? It will tell you. So you can decide to stop it right away, or you can say that, but it will be okay. I can finish the job and it will still be okay. So this is very useful. And then we have the occasion that the soft starter actually trip. The motor is overheated. It's too hot to do a start. So what can you do? Well, you need to wait for it to cool down. But for how long do you need to wait? You don't know. But the PSDX can tell you that. It will show a countdown timer until it is cooled down to do a new start. So you know if you just need to wait 15 seconds to do the next start, or if you have 15 minutes, so you have time enough to go for a cup of coffee or something and come back to the motor. These small things that we have added just to make the life just a little bit easier. And the soft starter will also monitor how the network is behaving. So it can detect if the voltage is fluctuating a lot and can show you that, so that you can get a little bit of an idea of if you have any problems in the network. This soft starter is designed to work everywhere in the world, and we have certificates and protocol to support that. So of course we have following the IEC standard, and the product is marked with that. But it's also available for the American, Australian, Chinese, and Russian markets. Right now, we are waiting for the certificate for the marine approvals to come. It's just a matter of weeks until they are ready. Then you can be used in different kind of vessels and ships. Also very good. So this is a global product. Let's go into the third scenario and the third value. Now we are talking about an end customer. This is a customer in Russia. This customer has used a soft starter in a very nice solution that is able to protect the harbor of St. Petersburg from the forces of the Baltic Sea. This is just not too far from Sweden, and it can blow quite heavily sometimes. And when it blows a lot of wind in the ocean, it can blow a lot of water into the city. And to protect themselves, the city has built a wall out in the ocean, just a few hundred meters away from the harbor. But since they have a working harbor, they need to have openings, doors that can open and close. And for this application, we are using pumps and our soft starters to run them. And this customer experienced that now, with our soft starter, they can use the pumps for twice the time. They are lasting twice the time. And they are reducing the cost of maintenance and service by 30%. And we are very proud about this. We call this increased application productivity. And I'm going to show you some really nice features that with this soft starter that allows the motor to do much more. We can be more flexible and productive with our motors. Let me show you. I will tell you about the new limp mode feature that will make the soft starter to continue to operate even when it's damaged. I will talk about the new jog feature, motor jog feature. And I will tell you about the new pump control that we have. Okay, but we take them one by one. We start with limp mode. Limp mode allows this soft starter that is 3-phase control to also operate as a two-phase control soft starter if one of the firesters would break. And this is great because a broken firester is the most common problem with a soft starter. It's not the circuit board, it's not the bypass, it's the firesters that has the biggest risk of being damaged. So to avoid this problem a little bit, to make it smaller, we have made sure that this soft starter can continue to operate with just control of two of the phases. And it still will have all the protections available, all the basic functionality like start and stop, and even torque control. All this is available. And the reason why we can do this is because we have the best two-phase control soft starter on the market. It's called the PSE. So we have included the PSE algorithms in the PSTX as a backup, as an emergency mode. So the idea behind this is that if something would happen to the soft starter, to one firester, the user can still run the motor until he has time to do the service. So he doesn't need to stop the production just because of the soft starter. He can continue to operate and get the spare part sent all the way from Sweden and then do the service when the spare part has arrived. Really nice. Then we have motor jog. Motor jog is something that I am very proud of because this will increase the productivity a lot. With motor jog, we don't need to run the motor always in full speed. With motor jog, we can run the motor in reduced speed. Not for as long time as we maybe would like, but for a shorter period of time, a few seconds, a few minutes. But it can be very good. For example, when you would like to position something, a conveyor belt needs to be synchronized with a machine. It can be a crane that needs to be stopped in the right position. Something that needs positioning. Before, you needed to use a drive to be able to do this. Now you can do it with a soft starter. And you can do this in 3 different speed levels. It's very nice. The fastest speed level is 33% of the speed. And then we have around 15% and 7%. Very nice. But the coolest thing here is that you can do this motor jog also backwards. So you can move the motor slowly both forward and backwards. Imagine how flexible you can be when it comes to positioning. You can run the motor, you can stop the motor, and then you can move it a little bit. It's very nice. So backward, forward in different speed settings, speed levels. And this is something that you can control from the keypad, through the field bus, with push buttons, any way you want. It's really nice. I would like to tell you about torque control. Torque control is a feature that we have had available for a couple of years, but it's so important that I would like to mention it for you. Torque control is used to avoid water hammering in pump systems. Do you know what water hammering is? It comes from when you are closing a valve or you are stopping a pump too fast. That when you do that, the forces in the water will start banging in the pipes. You have no control of what happens with the water. It will make a lot of noise, and it can even burst the pipe so that you have a leakage. This is a real problem existing in almost every pump system in the world. You can even experience it in your home, in the small pipe system you have in your home. So we have designed the torque control feature to avoid these problems when it comes to stopping the pumps. And in the past, people were using the normal soft starter with voltage ramp to be able to stop it and avoid the water hammering. But that is not good enough, and I will show you why. Because when you're running in full speed with the pump and you're using a normal soft starter, when you give the stop signal, what will happen first? Well, nothing will happen with the speed at first. And then after some time, everything will happen at the same time. And this is because some physical laws. And one is that when the motor is turning and the pump is turning, and even if you reduce the voltage, the pump would like to continue to turn. So the immediate response is that the current goes up, keeping the power at the same level. When the voltage gets low enough, then the current cannot pull up and it will stop very fast. This will cause water hammering, because even if you set a 10-second ramp time, you only get a few seconds of actual stopping time. And the stopping time is the important one here. That's why we introduced the torque control. And torque control was the result of a long time of engineering and science from ABB, together with one of the biggest pump manufacturers in the world. Together with them, we could try different algorithms to get the perfect way of stopping a pump. And I can probably say that our torque control solution is probably the best torque control available on the market, because we have put so much time and effort into getting it absolutely right. So what will happen? You have a full speed running pump, you give the stop signal, and the soft starter will decelerate the motor softly down to 0 speed and have full control of the pump all the way down. And that would give us full control of the water flow as well. Really nice. It's avoiding the water hammering problems from stopping pumps. This is something we have that is called torque control, and it's part of the pump control functionality. But we are also adding, I actually have a video to show you this. I think it can be nice to go through it. So in this video, we are comparing different starting methods and stopping methods to see the difference. So we have the PSTX compared to the conventional direct online starter. And this is what I'm talking about, water hammering. We have water flowing in the pipe system. Then we give a stop signal. What happens? The power can come back and hit the pipes, hit the pump, hit the valves, and create damage. And this is exactly what happens when we use a direct online starter. Then we try a voltage ramp. Well, we get a much softer start. I'm sorry, but the graph here is not very visible. But we get a softer start, so that's good. But when we stop it, we are giving the stop signal, but nothing happens. The pump is still running in full speed and water is flowing. And then it stops, and you still get the water hammer. When activating the torque control, you will see how soft and nice this will be. The start is very soft, and when we do the stop, we have a slow deceleration of the water and keep full control of it. And this is thanks to some real engineering work being done at ABB in Sweden in collaboration with a pump manufacturer. The next pump feature is the pump cleaning feature. Pump cleaning is very good to use in wastewater facility. You know, when you have the wastewater, you need to pump back the water from all the houses, all the industry, and to the cleaning facility to be able to purify the water. When you do that, you're transporting water that is not clean, it has a lot of material in it, and this material can get stuck into the pipes, into the pump, in the valves, and so on. And over time, this will reduce the flow through the pipe system, and the efficiency will go down. What is the solution to this? We need to clean it some way. And the most common way to clean it is to go to the pump or to the starter. You do a start, then you stop it, then you switch the phases so that you can do a start in the opposite direction. Okay? You do that because maybe backward flow can solve this. Then you stop it, disconnect the cables, put them back, attach them, and you do a start in the right direction. You stop it, and you have to do it a couple of times. It's exhausting. And you need to be there with a screwdriver to do it. But do you remember? I talked about how we can rotate the motor backwards with the PSTX. And we are utilizing this for achieving an internal pump cleaning feature with no need of any accessory, and you can do this from a remote location with the field bus. It's excellent. So we are utilizing two main features. The forward with a kickstart, giving a lot of torque forward. Powerful start that will help clean the pipes, and then we go backwards, try to clean it, and go forward again. Like this. Forward full speed, we stop it. We go backwards, try to get some of the material out backwards, and then we go forward again, and we can repeat this over and over again until the problem is solved. And we don't need to do any mechanical changes. So, very useful for wastewater pumps that exist everywhere. It's not only for the cleaning of water, it can be in different kind of process industries that has material in the water. Pulp and paper industry, for example, that can experience this the pump or pipe clogging as well. I'm going to show you how it works. So we have our pump system again, but now we have waste water coming through. And what happens? It can get stuck over time, maybe worse and worse. And the pressure is reducing, the flow is reducing, until the pump can almost stop from this. That is when you should activate the pump cleaning. With the pump cleaning, we go backwards, we go forward, we go backwards, we go forward, as many times as we need to get this clean. And then we can go as normal again. Did you see the crocodile? There's actually a reason why we put it into the animation. It's a story from one of your neighbors. It was in Colombia. A customer of ours, they're making pumps that they put into rivers to pump up water from the rivers and to spread out for farming or something like that. And they had made an installation with a lot of pumps, and one of the pumps didn't work properly. It had a low flow through it. And my customer, he told me that he was so angry because he wanted it to work. So he told the service engineer that, "You have not done a good job here. You need to go down there and fix this." And the guy said, okay, I will go down. Just stop the pump. And an alligator floats up on the pump. It was an alligator that was stuck in the pump. They were all afraid, of course. They ran away and hid. So it could happen. And pump cleaning would have solved this, because moving the flow backwards and would get rid of the alligator. So it's good use. It's good use. I would like to take you through a last feature, something that I think is quite exciting as well. This time we go away from the pumps and we go into ventilation and fans. So let me explain the application that we have in mind. Here we have a ventilation system seen from above, with two fans, these two fans, that are working in parallel to create a common flow of air, a double flow of air. Why do you have this kind of installation with two fans instead of one? There are a couple of reasons. One is that you can make them more compact. The big fan would be very big. It's cheaper to buy smaller motors and fans. And you can control the flow, because you can choose if you would like to run both fans for full flow and just one fan for 50% flow. But what will happen? You run both of them, and then you decide to stop one, and what will happen? I will show you what can happen. So we have the recognize the ventilation system. We are blowing air. We have full flow from both of them. We are stopping the fan on the right hand side until it stops. So far, so good. We have reduced the flow by half. But what happens? The flow of air can go two ways now. And it will. And that will cause the fan to start spinning in the wrong direction from the airflow. So you don't get the airflow that you intended to get. You now can do with the soft starter to increase the productivity, to get more out of your process. Okay, it's a true stop. Make sure that this stops. Just a short repetition. We have talked about 3 different topics here. We talked about how we can improve the reliability of the motor, how we can reduce the current to the motor, how we can make sure that it's warm and has a good temperature before we start, and how we can make sure that it's fully protected by just using the built-in devices in the soft starter. Then we talked about how we can improve the installation of the soft starter itself, how easy it is to use it, the keypad that is detachable with no extra cost, the bypass that is included with no extra cost, and the Modbus communication that is included with no extra cost. It's faster and easier to install the soft starter than ever before. And then of course I talked about how we can improve the productivity of the application, how we can secure that the soft starter is running even if it's getting a little bit broken. One virus is broken, we can continue to operate. Then we can run the conveyor belt in slow speed for positioning with the jog feature. How we can improve the behavior of pumps with the torque control and the pump cleaning. And of course last, how we can get the flow that we want from the fans by making sure that the fan that is supposed to be stopped is kept stopped. So just to give you an idea how this new product fits into our general soft starter range, it now consists of 3 lines of soft starters. We have the PSR, that is our compact range. This is a soft starter to be used for a small motor. This is a soft starter to be used if you want something that is very simple and basic, just do the soft start and stop, or if you have a lot of starts per hour, then the PSR is the best option. Then we have the PSE, our efficient range, that I like to call the perfect compromise between functionality and size. Because we have one thing in mind when we design the PSE. We would like to make an easy and reliable soft starter for pumps, especially smaller and medium-sized pumps. So we included all the most important features for pumps and removed the rest to make it as compact as possible. It's a really compact soft starter when you consider all the functionality that is inside. And then, of course, we have the PSDX, the complete alternative that can do all the things that I've talked about today, with a lot of application enhancing features that will help you and your customers to be more productive. And it is the best option for the medium-sized and the bigger motors. Okay, that was what I intended to have in my presentation. I have a possibility to show you a little bit about the HMI, but I need someone to tell me how we are doing with the time for that. Is the time okay? Do we have some more minutes? I think that's yes. So let me show you the HMI. I don't know how well you can read this, but I'll take you through it a little step by step. The first thing is this better? You can hear me? Perfect. Very good. The first thing that will happen when you turn on the soft starter for the first time is that it will ask you which language that you will use it for. So, in this case, I've chosen Spanish for you. Okay. Maybe the translator is on a break. Okay. Okay, do we have contact with the translator? Okay, can you hear me? Okay? No? Okay. Is it okay? We can try to show it anyway, and the translator might join. Okay? So what I'm trying to show here is how fast and easy that you can set up the PSDX soft starter. When you start the soft starter for the first time, the first question that you will get is, which language would you like to use the Softstarter for. And I have chosen English here for you. Sorry, Spanish for you. English for me, Spanish for you. Then we can set the time and date. It's good because we have an event log in the Softstarter. And to make the event log make sense, it's very good to have the correct time and date in the Softstarter. So that's the second question you can answer. The third question is, how big is the motor? What is the rated current? Okay? That's also it's the most important setting. So it asked after that. And then you get the question, would you like to see the same guide, same questions, next time you start the Softstarter? Or are you finished with this? Okay? So we are done. Now we are inside, now we started the Softstarter. The first thing that we see is that we can display different values here. And of course we have defined some values from the factory, but the nice thing is that you can change this. You can show what the Softstarter should display. And not only in one screen, you can have it in several screens. So you can show a lot of different values. So I go back to the first one. Here we are showing the voltage of the motor, the current of the motor, and the power of the motor. Okay? Then we're showing the actual voltage. Okay? It's very good. The phase sequence and how the motor is connected in line or inside the delta. Just some examples. You can pick almost whatever you want here. You can show the temperature of the firesters, the temperature of the motor, and how long time it will take until it will trip. Things I talked about. You can show graphs. In this example, I have the motor temperature as a graph. So I can see how the temperature is going up and down over the time. I can keep this data stored here. And I can show the time interval. I picked 15 minutes here, but I can select 1 hour as well. So you see the historical values. Very good when you wonder what has happened to the Softstarter. Here is an example that you can show 2 values and not only 3 values. Here I'm showing the voltage over time. And it's also possible to show a bar like this, like a meter. In this case, we're showing the current. Now I'm going to go in and do a setup together with you, just to show how easy it is. I press the menu button, and then I get into the menu system. The first option here is the parameters. We have more than 300 parameters that are possible to set up so that you can get a Softstarter that behaves exactly as you would like it to behave. But of course, this will take a lot of time, and we have helped you with this, because you can go into the second options, the assistants. If you go into the assistants and select that one, you can go to the application configuration. Let's select that one. Here we get a list of different applications. So you can pick the application that you have. And there are a lot of different applications available here. So let me pick the most common one, the centrifugal pump. So I select it. And now I can choose here. Would I like to keep the settings I've already set in the Softstarter, or would I like to change it to the recommended setting for a centrifugal pump? So the Softstarter has recommended settings for a lot of different applications. I would like to change it. Or are you sure? Yes, I am sure. Okay. Now we can fine-tune the settings a little bit. Or we can at least view what kind of settings we have. So we have received settings for pump. And we can go in and edit them. like this, or we can continue and then we are completed. So just with a few clicks, I have selected the language, the time, and I set it up for a centrifugal pump, and we are now ready to do our first start. It's too bad that I don't have a motor with me so we could do a start, but this soft starter is ready to do a start now. And if you would like to try this, we have 2 soft starters outside this room that you can try do exactly the same thing, and they are prepared so that you can do motor start and motor stop in a simulated way, in a demonstration environment. Okay, so that finished our presentation of the new soft starter, and I would like to thank you very much for your attention today.
Bien, muchas gracias al señor Carl Thorstensen. Gracias, muchas gracias. Bien, tenemos un presente, señor ingeniero. ¿Sí? Ingeniero Ricardo Santillán Chumbita, presidente del capítulo. Please, Mr. Carl Thorstensen. Aye. Bien, en estos momentos el ingeniero Ricardo Santillán Chumbitas haciendo entrega. This is Pisco. Okay. Gracias. Thank you. Bien, vamos a llamar al ingeniero Santillán. Ingeniero Santillán, por favor. Dale. Vamos a llamar al ingeniero Oscar Durán, gerente de canales de ABB S.A., la empresa que está auspiciando esta magnífica presentación, esta magnífica conferencia magistral. Hace una entrega al ingeniero Santillán, un presente de ABB S.A. El ingeniero Oscar Durán, gerente de canales. Está. A ver cómo se abre. Ahí está. Ajá. Bien, muchas gracias, ingeniero Santillán. Muchas gracias, ingeniero Oscar Durán, gerente de canales, y vamos a pedirle al ingeniero Oscar Durán, por favor, vamos a pedir a el ánfora, ¿sí? Por favor, a ver, pedimos el micrófono inalámbrico para poder movilizarnos. Vamos a ver el sorteo. Un teléfono o un micrófono inalámbrico, por favor, a ver. Bien, vamos. ¿Sí?
¿Me escuchan atrás? ¿Así? ¿Sin necesidad del micrófono?
No, ahí tenemos con el micrófono.
Buenas noches. Bueno, ¿me dan la palabra?
Por supuesto, recibimos al ingeniero Oscar Durán, gerente de canales de ABB S.A., la empresa que está auspiciando esta presentación y que hoy tenemos 3 sorteos, ¿no? 3 presentes, 3 regalos en esta oportunidad, en esta tercera jornada de la Semana de Ingeniería mecánica y mecánica eléctrica. Adelante, ingeniero.
Bueno, primero, como ABB y nuestra unidad de negocios de Low Voltage Products quiere agradecer al Colegio de Ingenieros y al capítulo de Ingeniería Mecánica y Mecánica Eléctrica por invitarnos y permitirnos participar en este evento que es muy importante para ustedes. Igual queremos darle las gracias por la participación de cada uno de ustedes, por permitirnos darles a conocer nuestro nuevo Softstarter PSTX. Ahora los vamos a invitar, vamos a participar en una rifa para que todas las personas que hagan falta por entregar el volante nos lo regalen para poder iniciar. Y después de la rifa los invitamos que tendremos un cóctel que va dirigido principalmente a ustedes.
Gracias, muchas gracias. Bien, vamos entonces con la rifa. Los que faltan, por favor, los que faltan ingresar sus tickets y conserven el número porque justamente va a ser el registro para poder acceder al número premiado, por cierto, ¿no?
Exacto, entonces bueno, vamos a hacer 3 premios.
Sí, uno por uno.
Vamos a iniciar, bueno, ¿cómo hacemos la dinámica? ¿Será que gana el primero que salga o el tercero?
El primero que salga, creo que todos dicen el primero que salga, ¿no?
Más rápido, ya estamos cansados en la noche. Bueno.
Entonces, los boletitos o los tickets que falten ingresar al ánfora.
¿Nos falta alguno? ¿Ya todos ya están acá?
¿Todos están?
Levante la mano si falta alguno, por favor.
Por favor, no vale tocar el que está en el asiento del costado para poner doble opción, solamente el que tienen en su poder, ¿ah? No vale el que está en el asiento que está vacío, ¿ah?
Bueno, entonces le damos vuelta, por favor.
Adelante, ahora entonces la señorita ABB va a girar. Ahí viene.
Bueno, uno, ya. Los 2 últimos, ahora sí. Ya, dale. Podemos. Bueno, entonces, última vuelta. Ok, abrimos, por favor. Sin mirar.
Atentos con el número.
El número 0309. José Martín Mesa.
Ahí está.
José Martín, felicitaciones. Una foto, por favor. Recibiendo el regalo.
Muy bien, recuerdo inolvidable. La señorita anfitriona de ABB.
Muy bien, felicitaciones. Bueno, no, ese es el que tiene que quedarse ellos. Ok, vamos con el segundo premio. Gabrielita. Ok, el segundo premio va a ser un cargador solar. Interesante, estamos en la parte de aquí. Ok, para smartphone. Sí, que es un cargador para smartphone. Ok. El 300. 0306. Fernando Neira.
¿Dónde está?
No está. Fernando, felicitaciones.
Es un cargador solar, ¿no? Para smartphone.
Para smartphone, así es.
Ya no va a necesitar enchufar al tomacorriente. Ajá. Todos ingenieros jóvenes.
Felicidades. Bueno, damos la última vuelta. Ahora vamos a entregar nuestro último premio. Nuestro premio mayor es una cena para 2 en el Swiss Hotel.
Pues qué bueno.
¿Dónde era? Faltó dónde era. ¿Que lo hacemos con el segundo que salga? Como para darle un
mejor,
poquito.
sí,
que no sea el primero, sino el segundo.
Pero,
bueno, solo voy a decir el número. Bueno, voy a decir nomás.
Cena para 2, recomendable para la esposa, no para...
Exacto. Ese salió y no es, solo voy a decir el número. 0089. Casi 0089, casi.
0089.
Bueno, y ahora sí, este es el ganador.
No va, ahora sí el ganador es el... para pareja, para
Bueno.
llevar a la esposa, claro, ¿no?
¿Cómo es el número?
Sí.
0121. El señor Miguel Ángel de la empresa Nestlé Perú.
Lechero. Lechero.
Felicitaciones.
Es una cena para dos. ¿Dónde es? ¿En el hotel?
Swiss Hotel.
En el Swiss Hotel, ¿no?
Así es.
Lleve a la pareja. Bien, creo que tenemos algo más.
Sí, terminamos, ¿no? Nuevamente los invitamos
Sí.
a un cóctel y nuevamente
Pero, o sea,
gracias por...
Sí, pero algo más necesitamos. Hay la entrega de la revista Energía y Mecánica, edición número 45. Ingenieros, por favor, ingeniero Ricardo Santillán, presidente del capítulo. Esta revista es una publicación muy importante que la van a recibir. Ingeniero, adelante.
Ok. En primer lugar, por favor no se vayan todavía, si no, no hay cóctel. A ver, señores, por favor.
Tomar asiento, por favor. El ingeniero Santillán tiene algo importante que anunciar.
Señora Ana María, por favor, ponga ahí un freno. Bueno, en primer lugar, estoy muy agradecido por la empresa ABB, la cual ha decidido hacer el lanzamiento, ¿no?, de su nuevo producto aquí en el Colegio de Ingenieros y en la Semana de la Ingeniería Mecánica y Mecánica Eléctrica. Muy amables, muchas gracias, ingeniero Durán. Muchas gracias al ingeniero, por favor, ingeniero. El ingeniero con el cual hemos estado coordinando absolutamente todo. Quisiera que me acompañe, ingeniero, si fuera tan amable. Ingeniero Zapata, estoy muy agradecido realmente con usted. Hemos estado coordinando desde incluso de la primera vez que vinieron acá a poder realizar también otra presentación, ¿no?, muy importante. Y hoy día, para presentar, digamos, también nuestra nueva edición de la revista Energía y Mecánica, revista a la cual nos comprometimos cuando estábamos, digamos, postulando, ¿no?, como una lista, como la lista 4, al capítulo de Ingeniería Mecánica y Mecánica Eléctrica. Ahora sí lo vamos a tener en forma continua y va a llegar primero en forma virtual a cada uno de ustedes. Por favor, los que no tienen el correo del CIPLIMA, le agradecería que lo tengan lo más pronto posible, porque por ahí va a llegar muy fácilmente. Y además tenemos una página web, ¿no?, que la está administrando justamente un directivo de nosotros y en la cual también ustedes pueden bajarla digitalmente, esta revista. Ahora, tenemos una versión limitada, por lo que a los ingenieros que nos están visitando en estos días de la Semana de Ingeniería Mecánica, van a tener la oportunidad de llevarse una revista, hoy día, mañana, ¿no? Igualmente le iremos llegar a las empresas, no solo auspiciadoras, sino a todas las empresas, digamos, del sector metalmecánico y eléctrico, ¿no? Bien, muchísimas gracias, señores, muy amable ingeniero Zapata, muchas gracias, y están todos ustedes invitados para realizar el brindis de honor aquí, por favor. Ingeniero Durán.
Bien. Sí, pero antes, ingeniero Santillán, el ingeniero Eduardo Zapata va a hacer el brindis, con usted acompañándolo, y a los señores de la mesa también, al ingeniero Carl. Ingeniero Zapata va a hacer el brindis,
Bueno, nuevamente en nombre de ABB, reiterar el agradecimiento por su participación. Nosotros muy gustosos aceptamos la invitación del capítulo de Mecánica Eléctrica para participar y sobre todo aprovechar siempre la visita de nuestros expertos de fábrica, ¿no?, poder difundir el conocimiento, porque no solamente necesitamos que el conocimiento y las formaciones se queden dentro de ABB, sino que podamos siempre hacer eventos gratuitamente y que nuestros expertos puedan difundir ese conocimiento. Por eso y por más eventos en los próximos años, doy un saludo, por favor.
Que muchas gracias a los señores representantes de esta importantísima empresa ABB, que esta noche ha estado con nosotros con una presentación, esta conferencia magistral a cargo del ingeniero Carl Torstenson. Gracias por esta brillante exposición esta noche. Thank you, Mr. Carl Torstenson. Gracias, ingeniero Santillán, presidente del capítulo, ingeniero Ricardo Santillán Chumpitas, al ingeniero Pablo Mendoza Palmi, secretario del capítulo, al ingeniero Oscar Durán, al ingeniero Eduardo Zapata, a la anfitriona de ABB también, un fuerte aplauso. Bueno, y esta ha sido la tercera jornada esta noche en la semana de la ingeniería mecánica y mecánica eléctrica. Y bueno, el brindis que estamos teniendo también gracias a la empresa ABB, bueno, es el servicio completo. Una magnífica conferencia magistral y por cierto, también el brindis con el cual estamos celebrando el transcurso de esta semana que continúa el día de mañana también. Mañana tendremos otra conferencia magistral y por cierto, el viernes tendremos un cierre.
Sí. Ok. Me dice acá el ingeniero Zapata, efectivamente que tenemos los equipos para poder experimentarlo, simulando, ¿no? La simulación con los equipos en físico que se han presentado aquí en la conferencia. Y bueno, quiero también aprovechar para invitarlos el día de mañana, que es el día central con la condecoración a los ingenieros que cumplen 25 y 50 años. Va a haber también una conferencia. Y también, obviamente, la empresa AAA es la que está auspiciando ese evento. Y el día de la cena, que seguramente muchos de ustedes van a estar invitados, también hay dos empresas las cuales están colaborando con nosotros, que son la empresa ABB, acá del ingeniero Chavarri. Realmente muchas gracias, ingeniero. Y de empresa Ingestal. Igualmente, muchas gracias a todos ustedes por hacer de este evento un éxito. Muy amable.
Bien, y gracias a Cecil también que el día lunes estuvo auspiciando parte de esta presentación. Bueno, creo que hemos tenido un lleno, casi lleno total esta noche. Y gracias, compartimos entonces, ingeniero Santillán, este brindis, compartimos con los señores de ABB, la señorita anfitriona y todos también los de la oficina del capítulo. Muchas gracias, señoras, señores ingenieros. Disfrutemos este brindis y por cierto, ya lo indicó el ingeniero Santillán para mañana, el día de la premiación, reconocimiento a los que cumplen años también como ingenieros mecánicos y mecánico-eléctricos.